So we are doing physics chapter 6, heat and energy, and this is the second part. This is energy flow and its importance. So let's understand what is energy flow in an ecosystem. First, let's start with the definition of ecosystem. थोड़ा सा biology है physics में, but related to energy, which is a physical quantity. So we have to study this. A unit composed of biotic components, that is producers, consumers, decomposers, and abiotic components, for example light, heat, rain, humidity, inorganic and organic substances, is called an ecosystem. So किसी भी इस ecosystem में we have got biotic components, abiotic components, and the environment which comprises of these components is known as an ecosystem. So ecosystem is everything what we see around us, including us. ठीक है, ecosystem can be healthy, can be thriving, can be fulfilling. Ecosystem can also be depriving. बहुत जगह पे we see that ecosystem is damaged, getting damaged due to destruction of trees, um, killing of plants and animals. So ecosystem depends on healthy growth of each and every biotic and abiotic components without harming each other, but you can say helping each other. The existence of living beings such as plants and animals depends on the flow of energy in them. Energy is needed for all the biotic activities. The most significant source of energy for all ecosystem is the sun. So sun is the most, you can say it is the uh, sun is the primary source of energy. Energy received on earth from the sun is utilized in different ways. Nearly 56 to 60% part of the incident energy is absorbed by the atmosphere. Nearly 10% is utilized in heating of water and land, and only 8% falls on plant. Plant absorb most of the energy falling on them. Out of the absorbed energy, plant use only 0.02% in photosynthesis for producing their food. They are called producers. So plants are the producers, and we see how the energy traveling or coming from sun to earth reaches to plant and used by plant for its own making its own food, that is for photosynthesis. Food chain. In ecosystem, photosynthetic plants and bacteria acts as producers. The food synthesized by producers is utilized by primary consumers such as a krill. Krill is a small fish. If you know what is a krill, very good. If you don't know, I'll show you the photograph. Yeah, so that's a krill basically. So we are starting our food chain from krill. Okay, so what they are saying is photosynthetic plants and bacteria acts as producers, and the food synthesized by producers is utilized by primary consumers such as krill. Yeah, so um, plants produce food, krill consume those food. The primary consumers are eaten by secondary consumers such as small fish. So krill is consumed by small fish, which is consumed, which is known as the secondary consumer. So here we have the producer producing food with the help of sun. Primary consumers consumes that food produced by producer. Secondary consumer consumes the primary consumer. Tertiary consumer consumes the uh, secondary consumer. Large fishes eat small fishes. Okay? And the man may be the last consumer in the chain of energy transfer when he eats the fish. The simple food chain is shown in the figure. So man is at the top of the food chain. Yeah. So figure 6.7, this is you can say complex energy flow in ecosystem in terms of numbers. Figure 6.7 shows the energy flow in the ecosystem. The producers, photosynthetic plants, synthesize organic substances by process of photosynthesis. That is, they bind the simple compounds with the help of solar energy into complex organic substances. The chemical energy so stored in the plants is called gross primary production. Okay, so basically plants store energy in them in the form of gross primary production. Okay, the producers themselves first use the synthesized organic substances in the process of respiration, in which some of the energy is used in oxidation of organic substances. तो प्लांट को खुद भी सर्वाइव करना है, तो जो केमिकल एनर्जी प्लांट में स्टोर हो रही है उसका एक पार्ट प्लांट खुद यूज करते हैं अपने ग्रोथ के लिए, अपने सर्वाइवल के लिए. ठीक है. द रेस्ट ऑफ द एनर्जी is called net primary production, is stored for growth, development and important metabolic processes. Okay, so let me put it this way, that chemical energy which is stored in plants, which is created by photosynthesis, which happens due to the sunlight. Okay, so this chemical energy stored is called gross primary production. So first this primary producers, they use certain amount of energy themselves uh, uh, in the process of respiration. Okay, which is the net primary production. Okay, let's read this statement again because this might be a little confusing. The chemical energy so stored in plants. Let's start from beginning actually. Figure 6.7 shows energy flow in the ecosystem. The producers, photosynthetic plants, synthesize organic substances by the process of photosynthesis. They bind the simple compounds with the help of solar energy into complex organic substances. Okay, so gross primary production, that is the chemical energy stored in plants by the process of photosynthesis, is first utilized by the plants in the process of respiration, in which some energy is used in the oxidation of organic substances. So respiration is done. Now the rest of energy is also used by the growth, development and important metabolic processes which are happening inside the plant body. So in figure 6.7, the gross primary production for the producers is 20,810 calories, out of which 11,977 calories is used in respiration and net primary production is 8833 calorie. Okay, so respiration में जितनी भी energy utilize होती है, that cannot be, you can say, stored. That is, once it is utilized, it is gone. But rest of the energy, which is 8,833 calorie of energy, it's stored in the plant body. Okay, and now the next consumers, that is primary consumers or herbivores, obtain their food from the producers. So this 8,833 calories are utilized by primary consumers. Okay, but not completely. Like primary consumers will eat only the leaves or the flowers. They will not eat the bark, the stem. They will not eat the whole plant. They will eat only some part of the plants. The rest of the plant is decayed. It goes to decay. Okay, so 5465 calorie goes to decay and 3368 calorie is consumed by primary consumers. Now out of this 3368 calories, primary consumers, they spend some energy in their own respiration, that is 1890 calories, and the remaining calorie is stored in their body, that is 1478 calories. Now these primary consumers are consumed by secondary consumers. So uh, the primary consumers are not completely consumed by secondary consumers, only their uh, their uh, meat or the body parts which can be eaten by the secondary consumers, they will be consumed. The bones, the other parts of the body which are not consumed, they remain as it is and they decay. So 1095 calorie of primary consumers energy is decayed. The rest of the 383 calories consumed by secondary consumers, out of which 316 calories are used by secondary consumers for their own respiration, and 67 calories are stored in their bodies. So out of this 67, when the secondary consumers are consumed by tertiary consumers, 46 calories are decayed and 21 calories are obtained by tertiary consumers, out of which 15 calories are used by tertiary consumers and uh, for their own respiration, and 6 calories are stored in their body. When these tertiary consumers die, this 6 calories, they go into decay. So can you tell me now how much of total energy is gone into decay? 5465, 1095, 46 and 6, that is 6612. And how much energy in total is used for respiration, that is metabolism, for every and at every stage for all the um plants and animals, that is 14,198 calorie. So if you add both of them, that is 14,198 and 6612, you get 20,810 calories. So none of the energy is you can say uh, none of the energy is created or destroyed in the whole process. The energy flows in the ecosystem from one stage to another stage without any degradation. Yeah, there may be some degradation, but there is never any destruction of energy or creation of energy. The total amount of energy remains the same, right? So energy flow in the ecosystem is linear. It moves in a fixed direction. At the end, energy reaches the to the degraded or unuseful state. It does not return to the source, that is sun, to make the process cyclic. The energy flow in the ecosystem can also be understood in the form of food chain shown in the figure. So you can also understand that the same energy flow in ecosystem with the help of food chain. So solar energy is absorbed by producers, out of which they use some energy in photosynthesis uh, and some in respiration, and the net production is 8833 calorie. When it dies, 5465 calorie is decayed, or you can say it reaches the state of it reaches the state of you can say um, decay, or you can say degradation, and the remaining calorie 3368 calories passed on to primary consumers. The same thing is carried over till the end, and when tertiary consumers die, 6 calorie of remaining energy goes into decay. So if you add up all the energy, it gives you the total energy absorbed by the producers from the sun. So what is the application of laws of thermodynamics in energy flow? The flow of energy in the process of entrance, transformation and diffusion in ecosystem is governed by the law of thermodynamics. Laws of thermodynamics. According to the first law of thermodynamics, the energy can be transformed from one form to another, but it can neither be created or destroyed, which we already saw. When certain amount of energy of one form is destroyed, then the same amount of another form of energy is created. According to the second law of thermodynamics, when energy is put to work, a part of it is always converted into unuseful form as heat, mainly due to friction and radiation. In all such cases, the total sum of useful and unuseful energy remains constant. In the 6.7 figure, The energy used in respiration and decay or death appears as unuseful heat energy because this energy does not reach to the consumer of next stage. So just like a machine in ecosystem, also the energy transfer is not 100% efficient. A portion of transferred energy always goes to unuseful form in accordance with the second law of thermodynamics. Okay, so this was theoretical part B of your chapter. Now you have to do exercise 6B as homework. I will see you in the next video. Bye bye.